Welcome to the show. I'm Nick Gromicko. Today we're in Denver, Colorado, and I'm with Jim Blackledge, and he was the project manager that helped build this building, and it's a green building. It's the actual EPA building, and although it looks like their lawn needs to be mowed, we're on the 9th floor of this building. Right, Jim?
That's correct, Nick.
Welcome to the show.
Thank you very much.
Tell me about yourself, and why do we have this stuff growing up here on the 9th floor?
This is not a mistake. We actually did this on purpose.
So if an inspector comes along and sees this, what is it? What is actually going on here?
These are actually sedum. We planted these on purpose. It's a 6-mix variety. They're in 2 foot by 4 foot by 4 inch deep tubs that we can actually move if there's a roof leak or something. There are a couple of reasons for this. One, we wanted to manage what we call heat island effect. The temperature off all of the roofs of these buildings downtown changes the microclimate by about 5 degrees. This lowers that microclimate temperature. Also, to manage stormwater quality here in Denver, you either need to hold that water in a tank in the building, or you need to filter it and slow it down. And that's the purpose of this roof. It filters all the particulates out of the air, slows down that stormwater as it runs out into the storm sewer system.
Great. Can we take a tour?
Love to.
Let's go.
Okay.
In a previous episode, we met with Stephen Kane. He's here today. Stephen, welcome back.
Thanks a lot, Nick.
He's from Namaste Solar Electric. In the previous episode, we had these solar panels on a residential property, and now we're on this commercial property. Are they the same solar panels?
They are. They're from the same manufacturer, SunPower. They're high-efficiency solar modules. This system is a 10 kilowatt array, which is about twice the size of the residential system we had seen a few weeks ago. It's a relatively small system for a commercial building, but it's a good way to showcase how PV can impact an electrical bill on a commercial building.
I'm on the corner of the building now with Nachi TV's green building expert, Kenton Shepard. Kenton?
Nick.
Always helping us out, thank you.
Yeah.
These concrete sidewalk tiles, they feel funny, they feel soft.
Yes, they do.
Tell me about them.
Well, these aren't really pavers. These are made from recycled tires.
So they're rubber.
They're made of rubber. Yep. They're waterproof. They won't crack and absorb water and break over time. They'll stand up to UV.
And I like them.
And they're comfortable to walk on.
They're
yeah.
comfortable. Now what about the concrete walls? Something's really unusual about these concrete walls.
In this EPA building, all the concrete has 25% fly ash, and fly ash is a byproduct of burning coal
a waste
to produce
product.
power. Yeah. So when you burn coal, when a power plant burns coal to produce energy, they produce fly ash also, and it's toxic. It's a pollutant, and by using 25% fly ash in all of this concrete, they bind it up and keep it out of the air.
That's awesome. This really is a green building.
It is a green building.
All right, let's go. Ken, tell me about this floor.
Well, the dark part of the floor is post-industrial waste, which sounds pretty nasty, but it's more recycled tires. So keeping some of those millions and millions of tires out of the landfills and out of people's backyards and making good use of them.
And this is cork.
And this is cork. It's a great, both floors are great to walk on, really comfortable.
They really are comfortable.
And they're help keeping toxins out of the atmosphere and out of the environment.
That's great. We're back inside the building now, and I see these little vents popping up through the floor. What do we have going on here?
Well, Nick, this is a different type of air conditioning system for a commercial building. This is called a UFAD, or underfloor air delivery system. Typically in buildings, we bring the air in overhead. We have to cool it to about 53 degrees. That's why we have people that complain about being cold all the time. This system, we actually bring the air in and we cool it to 62 degrees. So we're using less energy to cool the air. plus we're bringing in fresher air up to about 6 feet. Everybody in the building has one of these in their office or their workstation. Again, back to workspace and personal control, they can control the amount of air that is in their cubicle. They can't control the temperature, but they can control the amount.
But I don't see a ductwork in here.
No, the good thing about this, we've actually reduced the cost of construction for the building. This is a 16-inch high access floor. All of that ductwork that normally goes above the ceiling, we eliminated by putting the air system under the floor. You'll also notice that we have electrical and voice data cabling in here. We can remove this entire section of floor, reconfigure the electrical and voice data and not disturb anybody, and put it all back.
And no ductwork to play with.
No ductwork to play with.
All right, great. Here, from here, you can actually see the raised floor. The concrete supporting floor is underneath the gray area. The gray area is the area of the raised floor. Jim, what are you doing here? Flying kites or what?
You know, actually, Nick, this is a part of the solar control in the building, similar to light shelves. We've got a 9-story atrium with skylights at the top. We needed to bounce the daylight as deep as we could into the building. We looked at reflectors outside of the building, glass pieces inside the building, and finally came up with this concept. The architectural firm is out of Portland, Oregon, so we went to a sailmaker, had these things made, actually by the sailmaker. It's coated canvas, and on a really sunny day, you can see this light just bouncing around the atrium.
So there's sailboat sails.
Similar concept, yes.
Great. I'm in the fire escape right now, and normally the doors would have to be closed so that in case a fire breaks out downstairs, the smoke doesn't come up into the upper floors. But these doors are left open. They automatically close should a fire break out. The reason they're left open is to try to get the occupants to take the stairs more than they do the elevators. No, this isn't a break in the show. We're going into the men's room for a reason. Follow me. I'm with Ryan Wilcoxon. He's an EPA contractor, and he's going to tell us a little bit about this product.
This here, we have waterless urinals throughout the building, and the way these work is cartridges sit in their standard urinal, and you fill the cartridge with water, and then there's a sealant that goes in that holds any smells that urine would create, and then urine comes out through the bottom of the cartridge and drains out into the drainage system.
So it's a waterless urinal.
Yep.
Is it a new one?
It's new.
All right, then I'll take a look at it. Now, still in the men's room, we have a countertop here, which is a cradle-to-cradle product. It's made of recycled concrete and broken glass.
Well, you may notice that there are screws holding down the tiles on this floor. This floor provides access to the underfloor ventilation system. And there's something about this carpet also. There are 12 different types of carpet in this building. And they have up to 40% recycled content. Some are plastic, from a variety of products, but they're all very green. Most of the lighting for this building is natural lighting. The cleaning staff works during the day, so at night it's dark. During the day, there are various sensors that adjust the lighting depending on how much light is coming in through the windows. They use daylight sensors, which sense the amount of daylight, and they use motion detectors. So as you walk through the building, if you walk into a dark room, the motion detector picks up your presence and turns the lights on. When you walk out, no more movement, the lights go off. There's also a timed sensor system that turns the lights on during the day, shuts them off at night. So there are actually 3 approaches to lighting this building. You'll notice, looking around, there are a lot of white walls and white tiles on the ceiling. Those bounce natural light around the office, and so the amount of provided light, mostly fluorescent, is really very small. Most of it's natural lighting.
Now, Kenton, we're in one of the workstations that are in this building. What can you tell me about it?
Well, all these products and fabrics are certified by the Green Guard organization. They're all certified low volatile organic compounds, which are VOCs. This is recycled polyester. This is cornstarch, recycled cornstarch. And these counters are made from recycled wheat.
So it's wheat board. It's not oriented strand board or particle board.
Right, right. It's just it's using waste from agricultural waste, basically.
I love the ergonomic workstations in this building. These panels allow daylight to come through into your workstation. These panels are all acoustic, and it keeps the noise down. Also, the desks lift up so that an employee has the option of standing and working, and it allows the employer to determine who deserves a promotion. Okay, we're on the southeast side of the building where the light comes in from up high. We have these shelves here. What are they?
Basically, these are shading devices. There's so much window square footage here, so much glazing that you want to keep some of that summer sun out of there so that it doesn't get too hot inside.
It doesn't glare.
Right.
Workstations.
Glare and just adding heat to the inside. This helps keep the inside a little bit cooler.
So it's like a little shade. And the holes are for snow, I imagine.
The holes allow snow to drain down through there now.
So on the north side of the building here, you'll see those same shelves are vertical rather than horizontal. Why is that?
Well, the sun's at a different angle on this side, so they're doing the same thing to help breaking up sunlight and keeping the inside cool.
So it comes in at a lower angle over here, so they're vertical as opposed to being horizontal on the south side where the light's coming in and causing glare from above.
Right, so on the north side they're vertical, on the south side they're horizontal.
Right. Now I found these on the side of the building. They're the same sort of shelving we saw earlier being used for shading, but there are no windows underneath it, no windows next to it. I couldn't figure out what they were for. The architect told me they were just for design purposes. They are the cornice to the top of the building. The walls are covered with this bamboo, which is held together by a water-based adhesive. Bamboo is a fast-growing product. When you use less space in a building, you use less energy to heat it, to cool it, and to build it. These are movable stacks in the library, which is open to the general public and open to home inspectors who want more information. Jim, I want to thank you for doing the show with me. Stephen?
Thank you.
Kenton?
Nick?
We'll see you all next time.